Jai Hind to all of you. I am Dr. Gaurav Saxena. Today I have discussed the gradient of scalar and divergence curl and the Gauss divergence theorem and the Stoke theorem. So in this slide, we have to just represent that what is the gradient of that particular scalar field. So this is the first slides. So what is the meaning of gradient? So gradient always calculated of a scalar field and this which gives a vector field. So what is the meaning of this? Gradient is a scalar field which represent the magnitude and direction of maximum space rate of the increases of V. That means the gradient, suppose V is the scalar field and if we want the gradient of that particular vector, so gradient is defined del of V. So this gradient of that particular scalar field is defined how much rate this scalar field is to be increases. So that means the what is the meaning of this? If we given a scalar quantity V and we find the gradient of this, so this give a vector quantity, that means which is having a both magnitude and direction. So gradient of any scalar field is defined ki how much they are increase in a maximum space rate. So that means if this is the V and this increase, then the vector this scalar field is to be defined V2, where V2 is V1 plus delta V and V3 is defined V2 plus delta V. So how much rate this increases, this represent the magnitude of that particular gradient and which direction this they increases. So this is in this direction they have to be increases, so which represent the gradient of that particular vector. Then gradient, how we calculate the gradient in Cartesian coordinate system. So gradient we easily calculate the vector, the scalar field V is defined, and if we differentiate this with respect to the x in the direction of Ax, and if we differentiate this scalar field in the direction of Ay, and we differentiate this scalar field in the direction of Az, and we added in both the vectors, that represent a gradient of that particular vector. So the divergence, divergence of that particular vector is the defined what is the outward flux per unit volume, where volume is to be shrunk about the point P. So divergence is three types. Is the positive divergence, that means the total outward flux is moving from that particular point. That means this point P is a source point. If this point P is a source point, so we can say this is positive divergence. If this flux is to be converge this about this particular P vector or P point, so we can say this is negative divergence. If no convergence or divergence is placed about the point P, so we can say this is zero divergence. So divergence is defined about the point P, that means the how much outward flux per unit volume, how much outward flux we have to be calculated by the A dot ds, where A is defined the flux vector A and this is the differential surface ds having a closed surface S. So this is the total outward flux per unit volume we have to be defined here, where this volume shrink to 0. That means this volume is to be shrink about this point P. So divergence of any vector is represent how much outward flux per unit volume, where this volume shrinks about the vector at a point P. So first very important theorem which has to be asked in the EMFT, which one is Gauss divergence theorem. So Gauss divergence theorem states that the total outward flux of a vector field A, which is in a closed path S, which is same as the volume integral of the divergence of that particular vector. That means the first one is divergence theorem states that the total outward flux. So total outward flux is to be calculated by the A dot ds, where A is the vector field A, the total outward flux is to be defined by the A dot ds if we integrate this by any closed path S. So, this is the total outward flux in a closed path S, which is defined by this vector and is the same as the volume integral of the divergence of what is the volume integral? Triple integral, volume integral, the divergence, how, what is the meaning of divergence? Del dot A, and this is the dV. So, what is the divergence theorem? That means the total outward flux of a closed surface S, which is equal to the divergence of that particular gradient of that particular vector in the field of divergence. That means the volume, if we taking a volume integral of a divergence of that particular vector, which is equal to the total outward flux from that particular side. Suppose the proof of divergence theorem, suppose this is the volume V, this is the closed surface. So, what is the meaning of A dot ds? So, A dot ds, which is equal to the summation of A dot ds. What is the meaning of this? So, if we define here, this is suppose a 1, 2, 3 up to dash k. So, this volume is to be defined here by using this formula, where k is the kth element. So, easily we have to be calculate where A dot ds sk, which is if we divided by delta Vk, what is the delta Vk? Is the volume of that particular kth. So, if we divided and multiply this vector A dot ds divided by delta Vk or delta Vk, so this one is defined by the divergence of that particular vector. So, we have to be put here del dot A dV, and this is the what is this? Delta Vk is the dV vector. So, easily we have to be prove that A dot ds is equal to del dot A dV. Suppose one example I have to be just giving to you. If vector gr, any vector gr, or we can say is defined tan e raised to power minus 2z rho a rho plus az, determine the total outward flux of G in the entire surface of the cylinder, where rho is defined is equal to 1 and z is defined 0 to 1. Confirm the result by using the divergence theorem. So, what is the meaning of this? Suppose we create a one cylinder, and this is the z axis and this is the y axis, this is the x axis, or we can say this is rho. So, this is the arrow direction and this is az direction, and if this is phi, so this is az direction, a phi direction. Suppose the total outward flux of that particular cylinder is defined by, this is top flux, bottom flux and side flux. So, total psi, if total flux which have to be calculated by top flux, bottom flux plus side flux. So, if we calculate these three flux, so total flux by that particular cylinder we have to be calculated. So, this is total outward flux and this is equal to the G dot ds. Okay. So, we calculated this G dot ds in terms of top flux and bottom plus side flux. So, top flux, how we calculate it? So, top flux is to be calculated in the direction of Az. That means, in Az, what is the surface integral or what is the ds in Az direction? So, in the Az direction, what is the ds? ds is defined in Az direction, which is rho d phi. So, rho d phi in the direction of Az, this is ds. So, we put that G dot ds. So what is the value of ds in the AZ direction? Because we calculate the top flux. So top is to be given at the AZ direction. So ds is defined rho d phi AZ, and vector G is defined tan e raised power minus 2z rho a rho plus AZ. Okay. At z is equal to, what is the value of z here? Z is equal to 1, because in AZ direction z is constant. So we put the value of z is equal to 1 here. So this is amplitude, or so we taking this amount. So this is not dependent upon the rho and z. So what is the value of this? So you have to just put it a rho dot az, which is equal to 0. So this part is to be eliminated, and az dot az, which is equal to 1. So you just put constant term here, tan e raised power minus 2, you put the value of z is equal to 1. So tan into e raised power minus 2 into 1. This is constant term, and this one is rho d phi. This is double integral. So rho is defined from 0 to 1, because in the question which is given that rho is equal to 1. So that means that what is the range of rho? The range of rho is 0 to 1. So we put the value of rho from 0 to 1, and another phi is equal to 0 to 2 pi. Then we easily calculate what is the value of this. So rho is equal to 0 to 1, phi is equal to 0 to 2 pi, and you put the value of z is equal to 1, tan e power minus 2 here. Then you calculate it. So the value of top is tan pi e raised power minus 2. Then we calculate the what is the outward flux in the bottom side. So the total outward flux in the bottom side we have to calculate by using the formula there, where z is equal to 0, because in this case if we calculate the bottom flux, so z is equal to 0. So z is equal to 0, and what is the direction of this? So direction, we assume that this is AZ direction. So this is the opposite of AZ, that means that this is minus AZ direction. So that means the direction is minus AZ, and what is the value of ds? Ds in the direction of the AZ direction, which one is rho d phi. So rho d phi is in the direction of minus AZ. So ds is defined in this case, which one is minus rho d phi AZ, and vector G is defined tan e raised power minus 2z, where z is equal to 0. So e raised power 0. So tan into e raised power 0, which is e raised power 0 is 1. So we easily calculate what is the bottom flux. So bottom flux we have to be calculated by solving this integral, which one is equal to minus tan pi. So the top flux is tan pi e raised power minus 2, and the bottom flux we have to be calculate minus tan pi. Then we calculate the what is the side flux. So side flux in the direction of, what is the direction here? This is arrow direction. So first we calculate what is the surface ds, surface ds. How we calculate the surface ds? In the direction of arrow. So in the direction of arrow, what is ds? ds is rho d phi and dz. So we put the rho d phi and dz here, and the value of this one is rho in the direction of arrow. What is the vector? Tan e power minus 2z into rho. So tan e power minus 2z into rho, and rho d phi dz is here. So, the what is here? Rho square. So, what is the value of here total? Tan e raised power minus 2z rho square dz d phi. Then we calculate here. So, what is the value of this? So, in this case rho is the constant, because in the direction of arrow, that in the direction of arrow rho is constant, and in the given question rho is equal to 1. So, you put the value rho is equal to 1 here, and what is the value is here? Tan into 1 square into 2 pi, because if we integrate d phi, so they giving a value of phi, and we put the limit 0 to 2 pi. So, what is the value of this? 2 pi minus 0. So, the value of this is 2 pi, and we put the value of rho is 1, and this is 10. Then easily we have to calculate what is the value of this, which one is 10 pi 1 minus e raised power minus 2. To solve this integration, then we receive total top flux, which one is equal to this, bottom flux is here and side flux is here. Then we calculate what is the total flux, outward flux by this cylinder. Then we have to be just added side top, side bottom and side, which one is equal to 10 pi e raised power minus 2 minus 10 pi, this one is this, which is equal to 0. That means total net flux by that particular cylinder, which is equal to 0. So, by using the d dot ds, we calculate the total outward flux. In the next question, we have to be asked, then we verify this answer by using the Gauss divergence theorem. So, we extract what is the divergence of that particular vector and what is the volume integral, then we integrate that, then what is the value of this, then which is equal to the 0. So, first we calculate the divergence of that particular vector. So, divergence in cylindrical coordinate system is defined 1 by rho del over del rho, rho g rho, 1 by rho del over del phi g phi, del over del rho g z. So, 1 by rho del over del rho, rho and the direction of g rho. So, g rho is defined, what is g rho? G rho is defined 10 e to the power minus 2z into rho. So, 10 e to the power minus 2z into rho. So, 10 e to the power minus 2z into rho, and rho is also is multiplying that particular scalar field. So, that means what is the value of this? Rho square 10 e to the power minus 2z. Then 1 by rho del over del rho g phi, which has to be given here, which is equal to 0. So, easily we have to be calculate what is the value of, because in the direction of phi the vector is not given in that particular question. So, we easily calculate what is the del gz upon del z. So, you put the value of gz, what is gz? This is gz, gz is 10 e to the power minus 2z, that means 10 e to the power minus 2z, this is the in the direction of az. So, you easily differentiate this vector gz vector with respect to the z. So, what is the value of this? Minus 20 e to the power minus 2. So, what is the value of this? So, you just calculate here what is the meaning of the 2 rho 1 by rho, then you differentiate this with respect to the rho, which one is 2 into rho 10 e to the power minus 2z minus 20 into e to the power minus 2z, that means rho se rho cancel, this one is 2 into 10 20 e to the power minus 2z in positive form, 20 into e to the power minus 2z in negative form, that means which one is equal to 0. Hence, we can say g dot ds, which is also equal to 0. We have to be calculated by total outward flux, top, bottom and side, which is also equal to 0, and del dot g into dv, which is also 0. So, that means we can say the divergence theorem is to be verified Next question, what is the meaning of this? Curl of a vector. So, curl of a vector A is defined the rotational vector whose magnitude is the maximum circulation of vector A per unit area in the where the area is tending to 0 and the whose direction is the normal direction of the area when the area is orientation to make the circulation maximum. What is the meaning of this? So, particularly curl of that particular vector is defined where your vector is the rotational or irrotational. If I can say this vector is rotational vector, that means irrotational vector, that means the curl of that particular vector should be 0. Suppose vector A is defined here and the curl we have to be put here. So, curl is defined here del cross A, that means is the what is the magnitude of the maximum circulation which will have to be calculated by A dot dl, and what in a closed surface if we divided delta S where delta S tending to 0. So, we can say this is curl of that particular vector, that means that if this is point P, if maximum circulation occurs, that means the curl of P this out of P, that means the direction of that particular vector is here and the magnitude is maximum circulation. What is the maximum circulation? Which define the magnitude and the direction is perpendicular to that particular plane. So, always curl is defined of any vector field and gives the vector quantity. So, the vector quantity they have to be given here. So, what is the magnitude and what is the direction of that particular vector in curl form? That means the how we calculate the magnitude. Magnitude is calculated by the maximum circulation and the direction is perpendicular to the that particular plane. So, that means no maximum circulation is here about the point P. So, we can say the curl of that particular vector P is 0, or we can say this is a irrotational vector, not a rotational vector. So, Stoke's theorem that which has to be defined by the curl of that particular vector, that means the line integral of any vector A which is defined the surface integral of that particular curl of that particular vector. So, A dot dl which is equal to del cross A dot ds. So, easily we have to be convert line integral to surface integral by using the Stoke's theorem, and the volume integral to the surface integral to the volume integral we have to be converted by the divergence theorem. So, this is the proof of divergence theorem. So, first we have to be put it what is the divergence theorem states that A dot dl in a closed path L which is defined by the curl of that particular vector del cross A dot ds in the surface area. That means if we taking a LHS A dot dl, we have to be taking LHS. If we taking a maximum circulation, so this is 1, this is 2, this is 3, which have to be defined up to that. This is the kth vector, kth circulation. So, what is the value of this? This is the kth line Lk. So, if we divided by this surface area, what is the surface area? Delta Sk, and we divide and multiply this surface area of that particular vector line integral. So, this vector is to be defined by curl of that particular vector. So, we can say this is del cross A, and if we integrate here delta Sk, integrate in a closed surface S, that means where K is lies from 1 to P, total is P. So, that means this delta Sk convert to the ds. So, we easily convert line integral to the surface integrals. Thank you.